So we will start uh, mechanics or machine design section with a very simple program with projectile motion. So let us start with our mm, basic of projectile motion. So basically, what is a projectile? When you release any object at a certain velocity and some angle, so it will follow this trajectory and it will reach the ground or it will hit the ground after some time. And whatever the horizontal distance is covered, it will be called as a range and maximum height achieved in vertical direction. So we get some formulas uh, for this, and we know some standard formulas for this projectile. Let's say like displacement in x direction, that is horizontal direction, will be simply velocity in x direction into time, whatever the time will, let's say time will be different here, time will be different here, and final time, total time. Then displacement in y direction is nothing but velocity in y direction into time minus 1 by g into t square. So g is acceleration due to the gravity. So minus g will be because object is going against gravity here. So let us start with the program. So u, let's say, or let us call it as u0, that is the release velocity of the projectile. So let's say it is released at 40 meter per second. Let me add some comment. The projectile velocity. Then g will be nothing but 9.81 meter per second square, and it is nothing but acceleration, or simply write gravity. Now I need to find out the uh, x component and y component of the velocity. So before that, I have imported some libraries, Numpy as NP, matplotlib dot pyplot as a PLT for plotting the graph, and from NumPy I will directly import sine, cos and pi. Instead of using np dot something, we can directly import this as well. So x component of the velocity, so let us call it as ux is equal to u0 into cos theta. So we have not defined the theta. So theta, let us assume 45. So this is angle of projectile. So projectile angle. So this angle you can see theta. Then you need velocity component in y direction is nothing but u0 into sine of theta. And theta is in degree. You need to convert into radian. So into pi divided by 180. So radian. Similarly here also pi divided by 180. So these are the velocity components in x and y direction. Now we have to calculate what is the total time required to reach the ground. So let us uh, call this variable as a t total, and there is a formula for that. T total is nothing but, here I have written that for, so t total 2 into u1 uy by g. So is nothing but 2 into velocity in y direction divided by g. So in equations of projectile you will find these equations. Okay. So this is a total time. And to calculate displacement of projectile at every moment or every second, we will calculate displacement in x and y direction of the projectile for different time instances. So we will take some variable called t is equal to np dot linspace. So our time will change from 0 to, let's say, total time, t total, and we will calculate the displacement in x and y direction at, let's say, 100 points. So you have to define now what is the displacement in x, what is the displacement in y. So let us call variable sx for displacement in x. So this is a formula, that is the velocity in x direction into time. So it is nothing but ux into simply t, and sy will be uy into t time minus 0.5 into g into t square. So these are the displacements. And to plot the trajectory, so we have to take x displacement on x axis, y displacement on y axis. So do that. Before that, I will assign some figure size. Plt dot figure, fig size is equal to, let's say, 10 by 5 or 7.5, not 75, 7.5. And plt dot plot x-axis will be sx points and y-axis will be esy. And here I will use plt dot show and plot. So you can see the trajectory here. So maximum horizontal distance is about 160, maximum height is around 40. So reduce figure size little bit. Let's take 5. Okay, so this is a projectile and we will assign the limit to the y-axis. Plt dot y limit from, let's say, 0 to, let's say, 50. You can see now it's starting with the 0 here, and we can give the label to this. Label is equal to theta is equal to 45, and to show that label we have to add command called plt dot legend. So it will show theta is equal to 45. Let us add one more angle. So we will call this as a u theta 1. Let's say this is a theta 2 is equal to, let's say, 30. Okay. So second projectile angle. Let us call this as a ux1. This is a uy1. We will keep release velocity same. So let us call this as a ut total 1 here, uy1 t1. Then here we will calculate ux2 uy2. I will copy that. So for theta 1 this is equation, and for theta 2 here, theta 2, theta 2, and here it will be, let's say, x2 ux2 and uy2. So this is corresponding to theta 2, that is a 30 degree. T total 1 for corresponding to uy1, and T total 2 here, T total 2 uy2. Just make necessary changes. So here T1, then T2 is equal to, so let us copy this as it is. Let us here make change 1. Here it will be 2. And similarly sx1, sy1, t1, t1, and here also t1. And for displacement for second load case or second angle, sx2 and sy2. and time will be t2, here t2, and here also t2, and plot sx1, sy1, and copy second also, plt dot plot here sx2 and similarly sy2 and theta 30 degree and run it. So you can see theta 2 something is wrong. Theta 2 we have changed ux1 time 2 uy2 ux2 theta is we have changed. It should be something different, not the same. T1, sorry, here it should be ux1 uy1 ux2 uy2. Okay, then now it is different. So 30 degree will cover less distance than 45 degree when velocity is same. Also 45 degree projectile will reach maximum height than 30 degree. So here we can add symbols as well. How can I do that? So let's see. Instead of using this, so there is a in matplotlib I have seen R, that is a raw text, then put a dollar sign, then slash theta is equal to curly bracket, then put dollar for closing, then inverted comma, dot format, and I will use format for theta 1, and similarly for second angle as well. Here instead of theta 1 it should be theta 2. Okay, so theta is equal to 45, theta is equal to 30. So this way you can play with the values, you can change velocity, angle like this. So you can add here comment x velocity for your understanding, y velocity. So this was very simple program, and we will increase complexity in next program or further programs. So at the starting we have taken very simple program. So thanks for watching and best of luck.